Hi everyone, welcome to week 6 of the term. I'm Professor Rios. Hope you're doing well. This week we move on to a small block of climate and climate classification this week and climate change next week. And this week's pretty straightforward, but it's important. So understanding really what climate is and how climate is classified and how climate can go from one type to another in a relatively short area or elevation. So while this isn't the most complicated of material, it is pretty important because it helps you to really understand different regions of the world and why they look the way they do and why they experience the climate and the challenges that they do. So having said all that, let's move on to the presentation. And this beautiful image here, I love it. It's a picture of a savanna in Africa. So we'll get into why a savanna looks like this, why it's kind of dry, but there's some rain clearly because there are trees. So why does it look the way it does? And what helps explain that? These are the lesson objectives. So we'll look at the Köppen climate classification, which is a simple letter identifier of climate. And we'll talk about what the difference between weather and climate is. This was an objective in a previous lesson, but it's important and worth revisiting. So climate, what is climate? It's a pretty straightforward definition. It's a study of atmospheric conditions over many years. It's the average of weather. So this image here, which happens to be in Arizona, why does it look the way it does? What is it that leads to this versus a much more lush area? Okay. And all you would need to do is add water over a long period of time, and suddenly this would be covered in trees. So, there are very subtle changes that can happen that can make your climate change from one type to another. The idea of looking at climate, and tying back to the global circulation model, remember, low, ITZZ, high pressure on either side, low pressure on either side of that, and high pressure at the poles, means you tend to have all seasons wet near the equator, all seasons dry near those high pressure cells, all seasons wet where you have the polar lows or mid-latitude cyclones, and then all seasons dry when you get to the polar regions. And then in between, you either have a wet summer and a dry winter, or a dry summer and a wet winter. So there are places where seasonality is more of the norm, and there are places where it is pretty constantly moist. One of those places would be us in New York. So let's look at just some imagery of the driest place on Earth. This happens to be the Atacama Desert along the coast of Chile, where some parts have never ever received any rainfall whatsoever, at least measured. And as you can see, there is hardly any indication of that. This is all rock and dirt and salt. Any water might be some melt water from very, very, very high elevations. But this is the driest place on Earth. On average, some areas receive no more than 1 millimeter of rain a year, which would literally be like a 5-minute shower in New York. The wettest place on Earth, on the other hand, would be a place called Cherrapunji in India. It is along the hill, some of the approaching hills to the Himalayas in India. And there you're talking about orographic lift. Remember the wind over the mountain problem? This is one such place. And they get some ridiculous amount of rain. On average, around 450 inches of rain a year. The average. Sometimes a lot more than that. In some instances, you have the hottest place on Earth. And that happens to be right here in the United States. It's called Furnace Creek. I need to add the K there. In Death Valley, California, in July 10, Oh, let's go back. Here we go. On July 10, 1913, the thermometer read 134 degrees. On July 2020, it was measured at around 130, and many people believe this is the actual record because thermometers are a lot better now than they were over a century ago. But this is truly a hot place. I went to Death Valley in February, and it was already in the upper 80s. So that gives you a sense of how hot it does get here. Coldest place, of course, Antarctica, where the coldest temperature ever recorded was minus 129 degrees. Yes, that's not a typo. So that brings us to the idea of climate, looking at climatology using temperature and precipitation. And you can think of it as looking at just annual surface temperatures in January versus July and how that changes from hemisphere to hemisphere. Or you could look at temperature range, and we've talked about this already. In fact, I've shown these very exact images. The idea that Omaha is in the middle of the continent of the United States, and therefore it has a hotter summer and a colder winter compared to a similar city at a similar latitude like San Francisco, which is affected by the ocean. Therefore, it doesn't get as hot in summer, but clearly doesn't get as cold in winter. Okay? Or a city like Verkhoyansk in the middle of Siberia, which has an even greater temperature range from winter to summer. Precipitation, of course, that's driven by the global atmospheric circulation. So in this image, the darker the blue, the more rainfall you get. And as you can see here, that is usually around the equator where the sun is strongest, where the heating is greatest, and where you are generally in the proximity of the intertropical convergence zone, or that area of almost permanent low pressure near the equator. Okay? We'll see, and we're going to look at several climographs. So this one happens to be one from Islip, New York, and I just want to show you that temperature is in the red. That is the average low and high for each month. That arrow with two heads, that is the temperature range, the difference between the low point and the high point, and the blue bars at the bottom indicate precipitation in centimeters for each month. Notice how Islip, New York, like most places in New York, doesn't really have a dry season. Most times, most months of the year get on average around 10 centimeters of rainfall a year, and that's plenty to keep it from becoming a very dry place. Okay. So the Köppen system, it is called an empirical system. This means that it has a numerical basis. It isn't just someone's conceptual idea, it is actually based on numbers, and those numbers include precipitation and temperature data. It's simple, it shows an orderly pattern, and it gives you an indication of some climate type. So these are the idea of some of the benefits of it. There are 5 major groups, A, B, C, D, and E. So very simple with subcategories. And then there's a special category for climates that are considered highland climates, H. And the reason for this type of climate is if you find yourself in an area where you go up and down in elevation so dramatically over a short distance that it would be hard to measure an A, B, C, D, or E. Does that make sense? So, and, that's not really the case here in New York, but it is the case like in the Himalayas and in the Andes Mountains. Because you can travel 10 miles in one direction and go from 1,000 feet to, say, 17,000 feet elevation. And that makes a big difference. This is how your book breaks it down. You have your A climates, those are warm. Your C climates, those are mid-latitude mild. Your D climates, those are mid-latitude severe. E climates are polar. And then you have the 2 special types. The B climates are dry. So they're either semi-arid or totally arid, like a desert, and the highland climates. So you can classify it as AF, AM, AW. You can classify it as CSA or CFB, depending on a lot of the criteria. But there's a map in the book that shows you all the different types of climates and where each region of the world falls into. Okay. So here is from the book. So look at, New York State is DFB and CFA. So we sort of fall, the line is just to our north, like the Catskills region, basically. So notice that the climate is CFA all the way throughout the eastern US. And then you get into the western US where they're having lots of drought, and suddenly you have B climates, BW, BS. Okay. Notice that you find tropical rainforests, not surprisingly, in the middle of the Amazon. And if you look at the other side of the world, you find tropical rainforests in the middle of Africa, the Congo, or the Indonesia, Sumatra, Borneo, Papua New Guinea region. Okay. So that's the legend. So you can just simply look at the color and look it up in the map, and that pretty much shows you what type of climate that particular area has. It's a very straightforward system. It's easy to read, easy to apply. It's great for planning, basically. So let's look at a place like Monrovia, Liberia, and look at the rainfall in this region. It goes from very little to none to a lot back to little. So this is what's called a monsoonal climate. So here, the sun's energy is what controls the temperature and the temperature range. Notice it's pretty low latitude, 6 degrees. Temperature doesn't really change much throughout the year. Pressure controls the precipitation. So you go from low pressure in the summer to high pressure in the winter. And we've talked about these. Remember how we talked about the ITCZ and the subtropical high? Think back to the global circulation model. And then this begins to make a little bit more sense. So how would you classify it? Even though it says right there, AM, right there, you simply go to page 186 or 187 of your textbook. You see that Monrovia, Liberia is there. You open it up to that, you use the latitude, longitude, and you read the color code, and it pretty much tells you that this location is an AM climate. Okay? Even though I kind of told you here, it's already there, right? AM. But it's a pretty straightforward process to do this. And there it is. Notice AM from the textbook. Here's a little climograph. So it fits that AM or short dry season. Meaning the dry season is dry, but it doesn't last very long until you go back to a lot of rainfall. These are the 6 climates. Again, in a little bit more simplified fashion. There's that list. And looking at the A climates a little bit more closely, AF climates or A climates are basically broken down. They're all warm, but the difference between the 3 of them is the amount of rainfall. No dry season, short dry season, long dry season. That's the big difference here. An A climate would be like a tropical jungle, lots of rainfall, water balance in the positive, or notice short dry season or long dry season. That's what a savanna looks like. Not too dry, not too wet. Wet enough for some trees to grow. Now let's look at the B climates. B climates are either deserts or steppes. And so a BS climate or a steppe climate would be if you've ever been to eastern Colorado, Kansas, West Texas, western Nebraska, North and South Dakota. Lots of grass. It rains, it just doesn't rain a lot. Or a BW climate, which is a desert, the Sahara, the middle of Australia, the Mojave Desert, the Kalahari Desert, serious lack of rainfall, or the Atacama, as I showed you earlier. And again, a desert is pretty easy to like, oh yeah, there it is, dry, very little precipitation, very little vegetation. Notice they're usually, not always, but usually associated with high pressure, or cold ocean currents, or the leeward side of a mountain. Again, a desert has very little in the way of precipitation bars, as you can see there. And in the end, you have a big, big, big deficit of rainfall. Here's a steppe climate, a little bit more precipitation, notice. And here's where desertification, which is made worse by dry climates, is a big threat in the red or the orange. Okay, now we move on to sea climates. So sea climates are either Mediterranean, named after, of course, the Mediterranean region of Europe. So think Italy, Greece, the south of France, Spain, Portugal. Or in our own country, Southern California, San Francisco. There's a climate graph for a place like a place in Japan, which has a CFA climate, very similar to what we have here. And this is a sea climate in terms of what it kind of looks like. And you could pick up a whole bunch of other images to depict it. Here's a CS climate. Notice the summer is dry, the winter is wet. This would be San Francisco, for example. Very little precipitation during the months of May, June, July, August, September. Which is why California is having so many issues right now, because the amount of rainfall wasn't that big in winter, and then during summer they have no precipitation, so the drought gets made worse. Let's look at D climates. D climates are either milder or subarctic. So they're really broken up into two. So in New York, New England, we fall into the more mild type of climate for a D climate. Once you get into Canada or northern Europe, like Scandinavia or Russia, you get into these much colder subarctic climates. They're really, really cold, but they're not cold enough to be a tundra yet. So that's where you see, again, a place like, notice Russia, but not very far north, more on the southern end of it. And then the colder climates will be way up north, DW and DWA and DWD, where the temperatures in summer are mild, but in winter they are very, very cold, like minus 40 to 45 degrees. Okay. And finally, the pretty straightforward climates of the E type, tundra and ice cap. So really, this is only two places, Antarctica and Greenland. That's it. This is northern Alaska, northern Canada, northern Russia. Fits this description right here. And you do not find them in the southern hemisphere because there's not enough land. Okay. So that's what a tundra looks like. It's too cold underground. There's permanent frost. Therefore, trees cannot establish themselves. So the only vegetation is basically mosses, shrubs, some lichens, that kind of stuff. But it's too cold underneath for a tree to get a root structure going. There's your e-climate, again, tundra or ice cap. So, not many people live in an ice cap, scientists, researchers. Tundra, even not that many. A place like Barrow, Alaska, is at the very, very northern shore of Alaska on the Arctic Ocean. They get warm enough just for a little period of time, and it's just barely above freezing. So when you go there, it has that very sort of barren look to it. There's permanently frozen, not pretty exciting, very straightforward ice caps. Highland climates, well, this is a place in Africa. This is the mountain that is featured at the front of your course guide. This is Kilimanjaro in Africa. This is at the equator, yet there's snow. And that's because this mountain is 19,000 feet in elevation. So as a result, you're basically going through all these different climates in a very, very short horizontal distance. So this is the idea of H climates. Oh, let's go back to here. You go from a desert tropical region to subtropical to a C climate to a D climate to an E climate. And you can do that very short distance. So when you look at this image right here, down here in the basically valley floor, if you want to think of it that way, it's very hot, A climate. We're talking about equatorial Africa. If you go here, it can be very, very hot. But then you can climb, and suddenly you find yourself in a C climate and a D climate, and eventually you get to the very top of Kilimanjaro, and there are glaciers up there. And you may have only traveled maybe 10 miles in the horizontal, but you've gone up 19,000 feet in elevation, and therefore you can classify it as an H climate because it's very highly variable. So again, the Himalayas, the Andes, parts of the Rockies in the United States, the Canadian Rockies, fit this description. So that's the lesson for today. Straightforward. If you have any questions, let me know. Don't forget, as usual, the live study hour, or live office hour, rather, if you need it. Otherwise, I hope you're doing well, and I look forward to interacting with you. Talk to you soon. Bye.